you for everybody that's joining us online today. Welcome to today's webinar from the Global Partnership on Nutrient Management. And we're very happy to be working in partnership with a whole gaggle of organizations, including the Guru Gobind Singh Indraprastha University in India, the Sustainable India Trust, and we're working together with the International Nitrogen Management System, which has had support from the Global Environment Facility, the South Asian Nitrogen Hub supported by UK Research and Innovation, and of course hosted here by GPNM through the United Nations Environment Programme. So our topic today is assessment of nitrogen fluxes, impacts and solutions in South Asia. It's a key area as we will find out what is special today about South Asia. And I'm very happy that we've been working together in South Asia for several years through GPNM and these other labels we've just mentioned. For me, I think a key moment was going back to September 2017, when a group of us met together in the Maldives to look at the question of sustainable nitrogen management together with the South Asia Cooperative Environment Programme and the International Nitrogen Management System. And the question there was, how can South Asia move forward with this challenge and what to do about this challenge? Out of that meeting came a couple of agreements. The first was a draft resolution, which ultimately went forward to the United Nations Environment Assembly. And secondly, a proposal to establish a South Asia Nitrogen Hub. And we were very happy, of course, to receive funding from UK Research and Innovation through its Global Challenge Research Programme to establish this hub, which has been running since 2019. So that's the broad context. It's seen all 8 countries of South Asia working together with UK and others in this major cooperation. I think something like 40 research institute partners together, of course, with the South Asia Cooperative Environment Programme. I think I don't want to add too much more than that, other than to say, let's hear from the others. But before I hand over to our speakers, I would like to pass the baton to Dr. Tariq Aziz from Faisalabad Agricultural University, who is a key leader in this work and is the director of the International Nitrogen Initiative at South Asia Centre. So with that, over to you, Tariq.
Thank you very much, Mark. Good morning, good evening, wherever you are, dear colleagues, and a warm greetings to everyone joining today's important webinar on the assessment of nitrogen fluxes, impacts and solutions in South Asia. Let me begin by expressing my sincere thanks to UNEP Global Partnership on Nutrient Management and Sustainable India Trust and the university for organizing this very timely and strategic discussion. So as a regional director for South Asia of the International Nitrogen Initiative, as Mark has explained, I'm honored to be part of this critical conversation, one that reflects the increasing visibility, leadership, and scientific depth of the South Asia in shaping global nitrogen agenda. South Asia is both a global nitrogen hotspot, particularly for the ammonia emissions and a region of emerging solutions. The region is home to high fertilizer use, intensive farming and expanding livestock systems with rapid urbanization and industrial growth that impact the nitrogen cycle and also the air and water quality, biodiversity loss and raising nitrous oxide emissions, all with serious health and environmental issues. Despite of these challenges, South Asia is not just reacting, it is shaping global response strategies with bold political actions, regional collaboration, and scientific innovation. And it has emerged as a global leader in sustainable nitrogen management campaign, driven by its proactive engagement in science policy and international collaboration. Its leadership is exemplified through regional initiatives like Mark has said, South Asia Nitrogen Hub, active contribution to the international nitrogen management systems, and very importantly, the advocacy at various global forums, such as United Nations Environment Assembly. We have successfully organized many side events. One was at United Nations Environment Assembly, then COP29, and high-level political forum, UNFCCC Climate Bone Conference last year, and this year we are also going to participate. So advocacy at global forums such as these, this collective commitment from South Asia is setting actually a precedent for integrated nitrogen policies and actions worldwide. Today's webinar continues that leadership by focusing on the evidence base and policy pathways for the South Asia and also the globally. So through collaborative presentations and discussions today, we aim to assess nitrogen fluxes and impacts across the countries and the systems. And we want to explore the synergies across climate, food, air, and water policies and the systems, and support countries in integrating nitrogen into actions, into NDCs, and very relevant to the Resolution 5.2, which says that the National Action Plans, so investment framework. As INI South Asia, we are proud to partner with GPNM, SNNM, and the national governments to bridge science and policy for better nitrogen governance, to scale up nitrogen smart technologies and its awareness and the good practices, to promote equity, inclusiveness, and the regional cooperation in line with the SDGs and the Paris Agreement. And I'm happy to share that the South Asian Nitrogen Hub, INI, in support of South Asia Cooperative Environment Program, is also working on the South Asia Roadmap for Sustainable Nitrogen Management. So this is one of the regional, you can say, the leadership. To conclude, I believe that the region has the science, the political will, and the collaborative spirit to become a model region for the sustainable nitrogen management, which is need of the time. Let us continue this journey with ambition, transparency, and shared commitment for our environment, our people, and the future generations. And I wish this webinar great success and look forward to the enriching discussions ahead. Thank you.
Yeah, thank you very much, Tariq. And we're going to go on now and hear some of the evidence. And this is a presentation by Dr. Tapan Adya, who's professor at the Kalinga Institute of Industrial Technology in Bhubaneswar in India. Tapan Adya is also the co-chair, co-director for science of the South Asian Nitrogen Hub. And the work that you're presenting, Tariq, also sits within the context of the international nitrogen assessment. So as part of that international assessment, what is the story in South Asia? So let's hand over to you, Tariq, and then Professor Raghuram will follow up with further reflections on this.
Okay, thank you very much. Can I upload the this thing, share my screen?
Please do.
Is it visible?
Yes, thank you. And if you make it full screen.
Yep, I have made full screen. Is it okay?
Yep.
Yeah. Greetings to all the participants, Mark, Tariq, and Raghuram. I am presenting a basic database for the reactive nitrogen fluxes in South Asia, flows, impact, and solution. I am speaking on behalf of all the members of the South Asia Nitrogen Hub. Nitrogen issues, as has been pointed out, is a role in sustaining the life process on the earth is well known. But the problem appears when reactive nitrogen is released in excess to the environment, causing environmental issues. However, these issues make an obdurate challenge whether South Asia will be able to feed its population. I will come to that why it is so, and not worsen its already substantially impacted environmental and other developmental concerns. The South Asian general assessment and features, see the comprising of 8 sovereign countries, Afghanistan, Bangladesh, Bhutan, India, Maldives, Nepal, Pakistan, and Sri Lanka. This South Asian region is unique in the sense that more than 1.86 billion people, it is home to the 25% of the global population, and is one of the world's most densely populated regions with only 5% of the world land mass. and 14% of the global arable land, world's forest area, 3% of the world's forest area, very less forest area, and 4% of the world's coastline. This is the general land use and land cover map of South Asia with all the countries shown in this map. Now, in the South Asia regions, the main factors influencing the nitrogen flows are the strong N exchange over the thickly vegetated, I mean cropped regions, because this is very important from the viewpoint of agriculture. Strong agricultural activities with organic and synthetic nitrogen fertilizer in a mostly cereal-based cropping system. The huge amount, excepting of course Maldives, there is an island country, and then agriculture is not that intensive. The huge amount of animal excreta generated by the enormous cattle population and the high amount of municipal solid waste produced at the densely populated regions. So these features make these countries a coherent unit. Now, why South Asia? A global hotspot for other gaseous losses. I think some selective maps are shown here to see the South Asian region, the intensiveness of nitrogen oxides, nitrogen dioxide, and ammonia in this region. Now, relative differences from global means, these are the two columns. One is 1970 on the left and 2015 on the right of the ammonium, NOx, ammonium, and nitrous oxide. So this shows that between 1970 and 2015, the color code is given on the right-hand side. And you can see the color has increased, indicating that all the gaseous N content has increased in the atmosphere of this region. When we analyze the N emission trends from 1985 to 2015, showing the different sectoral sources, we divided under three heads. One is the total N emission, then the kilogram N per capita, and the kilogram N per dollar GDP. We find that the agriculture is the major source for nitrous oxide and ammonia. For NOx, actually, it is the energy and the transport are more important. The black bomb on the top is actually the global basis. This is based on the calculation derived from EDGAR database 5.0. Being in agriculturally intensive region, it depends, and that too cereal-based cropping system. It uses huge amount of nitrogen fertilizer. I have shown in two blocks. One is the per capita at the top and the per hectare cropland on all the 8 countries. And you find that per capita use is more in Pakistan, followed by India, Sri Lanka, and Bangladesh. But when you come to per hectare cropland, largest use is actually in Bangladesh, followed by India, then Pakistan and Sri Lanka in that order. The other countries, they are very minor users for the nitrogen. This is a global average of fertilizer in application. You can see that among all the 3 cereals, maize, rice, and wheat, over the years it has been shown that this is maize is the major largest consumer of synthetic nitrogen, followed by rice and wheat. Now, this scenario, when we put it under the South Asian countries, this is a data taken from 2000 to 2020, and all the databases has been collected. You can see at the top we have got maize, followed by wheat and rice. The countries like Sri Lanka and Maldives, they use a very large quantity of synthetic nitrogen fertilizer. And these are, of course, data set only. So this cannot be taken into. But then the red line in the middle is shown. This shows the surplus beyond an accepted standard norm of 50 kg N per hectare per year. Now, for maize, you can see that Nepal and Bhutan, it is at the lower end of the nitrogen input, but their efficiency is very high. This indicates that they are mining the nitrogen. For wheat and rice, both India and Pakistan uses large amount of actually using excess of nitrogen fertilizer. I think in that sequence, the best thing is that of Bangladesh, which shows a Bangladesh shows a much higher input. But in case of India and Pakistan, the nitrogen efficiency is quite low. Actually, lowest is in Pakistan is around 31%. Now, similarly, for the livestock population also, I have put into two sets. On the left, two blocks, two columns, rows rather, are livestock population, and on the right, two rows is the collected N component in the collected or managed manure. These are the two sets. One is 1970 and another is 2017. The number of cattle population, livestock population has increased. So also the amount of the manures. And one of the interesting thing is that the goat population has increased largely because this is used as a common source of popular source of meat in this part of the world. Now, the another interesting thing I would like to show that the poultry that is here, the poultry has increased like anything, both layer as well as the broiler several times, and so also the menu. Sorry. Now, this when you calculated the input-output balance of NR in South Asian agriculture, we have put here into different decadal lines. 1970, 80, 80, 19, and the last one of that group is that of 2070 to 1970 to 2018. The inputs we have shown from the different angles like nitrogen fertilizer, seeds, and then nitrogen deposition, BNF, then crop residues, etc. These are the things which are being included. Among the output, we have taken two units, that is crop removal, this portion, and the losses. Now, on the right-hand side, we calculated the balance. As you can see, the 1970 to 1980, the balance was negative. It was around 1.6 or so million tons per year, which reduced in 80-90, showing that it is less than -1. In fact, the scenario became grim in 90-2000, where it showed for the first time a positive balance of around 0.25 or 3 so. And then highest was actually 2000 to 2010, was 1.3 million tons positive balance. This started reducing slowly. This reduced slowly by 2010 to 2018, and overall for this group period, we get a very marginal negative balance, indicating that probably the soil environment is getting saturated with the synthetic nitrogen. We have also checked the waste and wastewater. If I can just mention the values between 2000 and 2015, this is the data from UNFCCC report, 295% increase in the N2O, and average annual percent increase is India, 14% is the highest, and Bangladesh is 4.09% is the second highest. The other sector is that of the energy use and the profile of NOx and N2O emission from energy use. NOx emission is largest is in case of industry, in case of the road transportation, followed by industry and electricity generation. The sector-wise percent increase also in the ranges in the same values are shown here. For N2O, the largest is that of the from the 14.92 is from the residential energy use, and then we have the followed by electricity generation and industry and other things. So this indicates that there is a increase in the NOx and N2O emission from 1990 to 2017. Now, this emission leakage of the agriculture of the reactive nitrogen is brings in damaging impact on as per wages concept, that is water quality, air quality, greenhouse gas balance and climate, ecosystem and biodiversity, and the soil quality. Now, the following key areas are needed to be considered: improving the performance of fertilizer, improved management of biological infection, improving performance of livestock production, improved use of proper cycling of organic end resources, reduced food wastage and balanced meat and dairy consumption, and measures to improve landscape resilience to air pollution. Now, this comes with the reducing the nitrogen waste. We don't mean waste here actually is not is going to some other sector, not intended. That's what way it is called, taken termed as waste, and achieving net zero. If we can reduce the reactive nitrogen content, probably up beyond some time. So now having the nitrogen waste and achieving net zero emission, these are ambitious goals. And this is possible by two ways: drastic reduction in use, which is difficult for population pressure because you have to feed the growing population, and increasing nitrogen use efficiency. This is a more sensitive approach with new technologies, innovation, new molecule, nanofertilizer, urea inhibitor, and nitrogen efficient crop varieties. Some success stories have already arrived. Neem coated urea in India, leaf color chart in Bangladesh and India, urea displacement in Bangladesh, then the soil health card in India, and novel N fertilizer, sulfur coated urea in India, we call it golden urea, and also other novel formulations from Pakistan, which is in the pipeline. Now, this projected impact of having nitrogen waste on N2 emission in South Asia is that if it is a business as usual, the blue line will increase N2 emission by 34% by 2030 and 60% by 2050. If we introduce some of the measures which has been mentioned earlier, having N waste may reduce the emission by 19% by 2030 and 30% by 2050. So in my concluding remarks, I would like to mention that better quantification of reactive N scenario in South Asian region is very essential for a more accurate understanding of the global N cycle, as well as for the development of a realistic international N management system. Given that South Asia is the most populous and the fastest growing region, I have mentioned about the agriculture, the waste, and the energy consumption. This comes with a distinct socio-economic, cultural, and climatic profile. This region offers a topical testing ground for validation of assumptions made on the basis of experience from other regions. This could in turn enable adoption of more informed means of estimating the region's N budget. We have made a tentative N budget for South Asia, as well as its contribution to the global N budget. And these are mostly being the nitrogen fertilizer, mostly being subsidy driven. Reducing wastage would lead to a win-win scenario for both the region's environment and the country's economy. So just a formal note of acknowledgement, 38 researchers from 8 South Asian countries contributed intensively, forming the backbone of this presentation. INMS and SNNM program for generously funding the research. Professor Mark Sutton, co-chair UNEP GPNM and director SNNM project for effectively steering through, and KIIT, Kalinga Institute of Industrial Technology, deemed university for hosting the India hub of the SNNM program. Thank you.
Thank you so much, Tapan, for that really comprehensive overview of the challenges and solutions in South Asia. So we're going to pass over now to Professor Raghuram of the Guru Gobind Singh Indraprastha University, where Raghuram is the leader of the Center for Nitrogen and Nutrient Management. Over to you, Raghuram.
Thanks, Mark. I'm glad to be able to assist the UNEP GPNM in conducting these webinars with the help of our university and the Sustainable India Trust. In this series, we are drawing from some of the work that we did under the INI, International Nitrogen Management System project, INMS project, and also from the part of the work that was conducted under the South Asian Nitrogen project that you had mentioned. Sangeeta is here. She has also been a contributor to this project. Many of the partners and panelists who are here have helped us in bringing together data from across the entire region. So the few points that I just wanted to add to highlight from the presentation that Tapan has made, I could show you slides if you want, but if it saves time, I just want to drive home the main point that if you look at the overview of the 3 major nitrogen species that are a problem in our atmosphere, in South Asia, we are looking at nitrous oxide, ammonia, and NOx. But if you take all three of them in terms of their total contribution to the environment, nitrogenous pollution in the air, we find that NOx is the most highest emitted nitrogen species, followed by ammonia and nitrous oxide. So that means that the priority for reducing these species of nitrogen, because they are handled by different ministries involved in different sectors, have to be decided accordingly. Up to 70% or more of all the NOx comes from fossil fuel burning industries and transport. And that's combined with ammonia, 86% of which comes from agriculture, forms these particulate matter. And South Asia is also a global hotspot for particulate matter pollution, PM 2.5 and PM 5. And I think 70-80% of the world's most polluted cities in terms of particulate matter alone are in India and the rest of South Asia. So from the point of view of addressing reactive nitrogen management, which also has serious impacts on health and visibility and air quality, NOx is of massive importance. And because both NOx and ammonia together contribute to particulate matter formation, ammonia becomes the next most important issue to address. Now, I was looking at the hierarchy of the contribution, for example, of NOx between the various countries of South Asia. It seems to roughly follow the size of the country. India has the maximum NOx contribution, followed by Pakistan, followed by Bangladesh, and then Sri Lanka, and the rest are small. But if you look at per capita, this is something that I'm sure was there in the slides presented by Sapan, but may not have been noticed. Per capita, we were looking at this data carefully. NOx emission is the highest in the smallest region country of South Asia, which is Maldives. So per capita NOx emission is highest in Maldives, followed by Sri Lanka, followed by Pakistan. So it's actually going in the reverse order. So the smallest countries have the highest per capita NOx emission. And as you grow up in size, the per capita NOx emission is increasing. And if you take Afghanistan, of course, is the lowest in all the species. So that's something. As I just wanted to flag this issue, that NOx and its contribution to PM 2.5, how this looks at in terms of total contribution versus per capita contribution. This is an important aspect for governance. The other major point I wanted to make was that ammonia control becomes extremely important. And since most of it, 86% of it comes from agriculture and livestock, including manure management, urine management, the percentage of manure recycling, at least in India, is very low, at best 25%, probably even lower or around that range in other countries of the region. So there is a huge amount of manure that is not being recycled and used, and that's also contributing to the emissions as well as water pollution due to various nutrients emitted from there. And if that was increased, that would reduce the amount of dependence on fertilizer. So that's an important governance point. The third most important point I want to make is, if you look at the total area under the 10 major crops, especially food crops, if you take the major cereals like rice, wheat, maize, anywhere in the world, these are the top 3 cereals, including in South Asia. And then you take all the total of various legumes that are produced, both grain legumes and oilseed legumes. The ratio of legumes to cereals is among the lowest in the world, in our part of the world, in South Asia. It is below 29% legumes versus 71% cereals. And that ratio is probably even worse if you look at the data in individual countries. In India, it is probably 10:90. So I think in the whole region, and particularly in India, the shift away from legume-based cropping systems, legume-based crop rotation, intercropping, has locked this region into fertilizer addiction, fertilizer dependence, and losses that accrue due to high mobility of the nitrogen species in inorganic fertilizers and their high rate of emissions, as well as losses into water supply. These are the major points that I wanted to make. That the per capita emissions actually follow the reverse order in terms of total country emissions. And B, the legume rotation can by itself, and of course combined with manure management, if you double or triple the current level of manure utilization from 25% to 75%, you could really significantly reduce the fertilizer dependence. And if you could bring back legumes into every cropping system, you could literally halve the fertilizer dependence within a span of whatever time it takes to make this transition. So these are, I would think, the most important areas that need to be addressed, apart from, of course, fossil fuel dependence and other issues related to net zero commitments and sustainable development goals. I would stop here, and I would rather like other panelists to add their points, and would be glad to step in during the rest of the discussion.
Thank you, Raghuram. So that's an excellent start off for us, and we're now going to come to three panelists. I introduce Dr. Umar Nahia from the Bangladesh Rice Research Institute, where you are Principal Scientific Officer. Dr. Sangeeta Bansal from the Sustainia India Trust, where you are Project Officer. And Dr. Shazla Mohammed from the Maldives National University, where you're a Senior Research Fellow in the Research Development Office. So thanks very much for joining us, and I want to give you first in turn a chance to make your pitch for the issues that you think are each important, and then we'll come to the questions. So let's start first with you, Dr. Nahia. Now we can't hear you at the moment, Umar. Can you? No, we have no sound. I'm sorry. That's not working. Should we try to get that working, and we'll go to one of the others first, and then hopefully you can get that working in a minute. Oh, now I can hear you, I think.
Okay.
Thank you.
Then, it's okay.
Yes, that's excellent.
Assalamu alaikum, and good afternoon and good evening to all of you. Greetings from Bangladesh Rice Research Institute. Thank you, Professor Mark Sutton, Professor Tariq Aziz, Professor Tapun Adhia, and Professor Raghuram for sharing your valuable thoughts on the assessment of nitrogen fluxes, its impacts and solution across the South Asia. Now, I would like to exchange some views and share a comprehensive overview of the current situation of nitrogen fluxes in the country, its impact and mitigation options that are currently being practiced in Bangladesh. We detect 4 major sectors are responsible for reactive nitrogen flux, that is for energy, industry, process and product use, agriculture, and waste. In the country, about 60% natural gas is used for energy generation. We use furnace oil and coal use only for 6%. Biomass fuels currently accounted for 36% of the total primary energy of Bangladesh and used mainly for cooking in cottage and small industries such as big kilns. Crop, livestock, forest and other land use emit major portion of nitrogen flux in the country, And globally, Bangladesh is a third largest rice producer, and rice is the primary crop, accounting about 75% of total crop production and covered 11.42 million hectares of arable land. The most popular nitrogen-based fertilizers in Bangladesh are urea and diammonium phosphate. In recent years, annual urea consumption was around 2.5 million tons and mostly used for rice production. Nitrogen fertilizer use efficiency in rice plant is low, and a lot of reactive nitrogen released environment due to application of nitrogen-based fertilizer. In the year 2019, it was estimated that nitrous oxide emission from nitrogen-based fertilizer was 6,000 gigagram carbon dioxide equivalent. And at the same time, indirect nitrous oxide emission from atmospheric in deposition, leaching, runoff was around 1,099,966 gigagram carbon dioxide equivalent. According to the published data of Rahman et al. 2022, due to nitrogen fertilizer use, ammonia emission was recorded 263 gigagram, and the combination of nitrous oxide and nitric oxide emission was 53.6 gigagram. It contributed, this article also reported that residues incorporation into the crop fields contributed to 13.70 gigagram, and on-site burning of crop residues and grasses produced around 5.24 gigagram of nitrous oxide in 2016. Beside crop sector, livestock sector is contributing significant amount of reactive nitrogen to the environment. Recent data from BBS means that Bureau of Statistics, that is national data, shows that total number of livestock was about 432 million, including the poultry. Animal house and manure management system is not up to the mark in the country. A lot of nitrogen losses occur due to volatilization, leaching, and runoff from the farmhouse and farm manure dumping system. According to FAO stat data in the year 2017, country's ammonia emission was 39.92 gigagram per year, and nitrous oxide emission was 7.28 gigagram per year from this sector. UNFCCC reported in the year 2019 that indirect nitrous oxide emission from manure management was around 6,000 gigagram carbon dioxide equivalent. And for the same period, indirect nitrous oxide emission and volatilization from livestock subsector were estimated around 1,500 gigagram equivalent carbon dioxide respectively. Whereas the contribution to the total indirect nitrous oxide emission from leaching and runoff was also estimated. It was about 400 gigagram and 462 gigagram carbon dioxide equivalent for both leaching and runoff, respectively. Freshwater fish culture consume nitrogenous fertilizer and organic fertilizer. And globally, Bangladesh is the second largest freshwater fish producer. And according to the conference paper of Rashid et al. 2013 and statistics from Department of Fisheries 2080, total ammonia emission from production in rice fish pond is about 85,000 tons, and unaccounted losses of nitrogen was calculated as 20,500 ton in the year, that 2017. Again, according to published paper of Rahman et al., combined annual nitrous oxide production from crop, fisheries, and livestock sector was, that is total NOxus was 600 gigagram, while emissions from nitrous oxide alone contributed 200 gigagram. However, in 2023, Bangladesh total nitrous oxide emission, including land use change and forestry, were estimated as 0.178 metric tons per capita. We know Bangladesh is a densely populated country, and daily waste generation rate is very high, that is around 0.75 kilogram per capita per day. So, and in the year 2019, population was 163 million, and nitrogen effluent generate 0.8 million ton that year, and total nitrous oxide emission from domestic wastewater was measured that time 6.34 gigagram. So in the year 2019, data from the Environmental Department shows that total nitrous oxide emission in Bangladesh were around 213 million tons of carbon dioxide equivalents. If we see for impacts, the impact of excess reactive nitrogen in the environment is not measured directly. Health hazard, environment pollution, losses of biodiversity, or economic loss data is not much available. However, we know reactive nitrogen in the environment has a wide range of negative consequences that impact air, water quality, human health, climate, and ecosystem. Nitrous oxide is the most important source of global warming potential, and broadly its impact is representing climate change impact. And Bangladesh is one of the most vulnerable countries to the impact of climate change, including sea level rise, drought, flood, and cyclone in every year. If we say the solution, agriculture is the vital sector for reactive nitrogen, so alteration or management practices can be an option to reduce nitrogen pollution. In agriculture sector, rice is major crop in Bangladesh, and that uses more than 70 to 80% of the synthetic nitrogenous fertilizer. So nitrogen use efficiency is low, and it is about 30 to 40% only. So if we can increase nitrogen use efficiency by genetic crop alteration or the agronomic management practices, then we can seize nitrogen pollution from crop sector by 80 to 90%. And to improve N use efficiency, we need precision nutrient management. That is the real-time nitrogen management according to crop need, that we use leaf color chart, soil test-based nitrogen fertilizer application. And we can reduce the synthetic nitrogen fertilizer use and promote organic fertilizer like compost, biofertilizer, and slow-release nitrogen fertilizer. Improvement of nitrogen fertilizer management is already practiced here. That is deep placement of urea fertilizer in rice field. That is urea super granule. And also as well, we can use, we develop some machine, and from the machine directly, we can insert it urea into the root zone. That is pre-yield urea, we can apply it. So use of urea inhibitor or nitrate inhibitor may be an option. However, it should be checked properly, its effect on soil biodiversity, as well as ammonia volatilization and nitrate leaching. Proper, because any synthetic and any imposing things may have the negative effect on soil biodiversity. Then proper management of animal house, urine and dung management, improving cropping, composting system, use it for composting rather than dump in open place. This is another option to reduce the emission from animal sector. In fish feed, always we apply the fresh urea, that is peeled urea and undecomposed manure to the fish pond. So in that sector, we can use the sludge or improve fish feed rather than apply direct urea or undecomposed manure. We can promote biogas plant to meet the fuel demand for cooking. And we know bioslurry is very safe manure and can be used for crop production. And now we are thinking that we are applying solar energy in agriculture, especially for solar pump running and field use also. And for waste management, it is really a problem. And if we can improve the waste management and food waste, kitchen waste, or biodegradable city waste, that we can add it as a fertilizer to the fields. And from wastewater effluent, we know we have the garments factory, and they are using a lot of urea. So the wastewater contain a lot of nitrogen. So the ETP plant, most of cases, they are not running properly. So if we can redirect this nitrogen and we can apply as fertilizer, maybe there needs some research and also some other activity. So in the national policy, nitrogen pollution should be separated
Doctor,
from
we should wind up in a moment, please.
Sorry.
We should move on in a second. So if you just conclude your remarks.
Okay. In the national policy, Nitrogen pollution should be separated from carbon emission, and among the reactive nitrogen particles, only nitrous oxide get greater attention in the country for greenhouse gas inventory. So we need strong policy and social awareness about manure and urine management from animal shed, and from both wastewater management from domestic and manufacturing factory. Last but most important issue is the lack of scientific data to prove the nitrogen pollution from different sectors. So once this impact data will be open, then only everyone will think for the solution. And another most that the subsidized system, the subsidy should be like on urea, it's okay, but not the pre-urea, like urea supergranule or other things. Thank you very much.
Okay, thank you so much. So we're going to pass over now to Dr. Sangeeta Bansal from the Sustainable India Trust. Sangeeta.
Good afternoon, everyone. Very much good afternoon to Tapan, to Raghuram and Mark, and my colleague Nahar for sharing her valuable views on the nitrogen fluxes, impacts and solutions in South Asia and Bangladesh. Now, I would like to give some brief overview about India. So as we all know that India is the second most populous country in the world, and we need a large amount of food to feed our ever-growing population. So agriculture is the main dominant sector, which is contributing majorly to our NR fluxes. As for the FASTAI data sets 2023, approximately 7 million tons of nitrogen fertilizers are consumed in India annually. But we have also observed, apart from agriculture, our economic activities are very sharply or rapidly moving towards other sectors like industry, transport, and energy services. And as per the data available with us, it has been observed that the fuel consumption in power sector has grown by 13% per annum from 1990 to 2017, whereas this growth rate in case of road transport is about 10%, followed by the industry sector with growth rate of 8% per annum in fuel consumption from 1990 to 2017. So as our demand is continuously increasing and our population is continuously increasing, so it is there that these consumptions and these emissions and fluxes are also going to increase in our environment. So when we talk about the different type of reactive nitrogen species in Indian scenario, I would like to mention, as mentioned by the Raghuram sir, that NOx is the most dominant reactive nitrogen species that has been found in the South Asia. Similarly, in India as well, NOx has been found as the most abundant NR compound at 10,025 gigagrams of concentration, followed by the ammonia at 7,074 gigagrams of concentration, and nitrous oxide at 895 gigagrams of concentration, as per the EDGAR datasets mentioned in the National Nitrogen Policy Report of India 2023. As per this, some recent datasets compiled under NMS from 1990 to 2021, maximum NOx emissions have been reported of about more than 300 gigagram per year from only from the road sector, followed by the industry and the power sector. So moving on with the nitrous oxide, maximum amount of the nitrous oxide is coming from the agriculture sector, which is around 77%. When we talk about the non-agri sources, maximum contributions comes from the power sector, which contributes about 9.16 gigagrams of nitrous oxide per annum, followed by the transport sector, which contributes around 8.67 gigagrams of nitrous oxide per year. And again, in transport sector, the maximum contributions come from the road sector, contributing around 5.62 gigagrams of nitrous oxide per annum. So with these facts and the figures, I would like to conclude that after agriculture, vehicular pollution is the main source of our NR emissions in India. So in the last of these values, I would like to mention that for India, based on indigenous data sets, that total N2 emissions from 1990 to 2017 were found to be 34 gigagram per year, while the total NOx emissions were about more than 4,000 gigagram per year from 1990 to 2021. So here I'm not mentioning the exact values of NOx emissions as the data are still under process of analysis for further publication. So exact values for NOx, at least I'm not mentioning here. So it is clear from this data set that a significant amount of these NR fluxes are entering in our environment and are badly impacting our human systems and our environment. And it has been found from the literature that about 387 districts in 21 Indian states are having nitrate levels in groundwater higher than the threshold values of 45 mg per liter, which is specified by Bureau of Indian Bureau of Indian Standards, that is BI standards, and more than 50 mg per liter than WHO standards for the drinking water, and they are causing and continuously leading to the increased cases of blue baby syndrome in infants and the stomach cancers in India. We have also noticed several incidences of fish kills in the freshwater rivers in the coastal areas, which is ultimately indicating the great biodiversity loss because of increased NR fluxes in India, as well as so many cases of eutrophication has been noticed in several statues of our major Indian rivers like Yamuna and the Ganga, and which are again getting polluted because of increased NR loadings. Now, when we are talking about the air quality, it has been found that at least one school child out of 100 has suffered from the asthma or any other respiratory allergy in Indian metropolitan cities like Delhi, where AQI touches critical values of about 500 to 600 in winters every year. So these data sets indicates that our situation is getting very worse and we need some strong and substantial solutions so as to fight these increasing NR fluxes in particularly in India. So when we come talk about the solutions, so many options have already been mentioned by my colleagues in case of agriculture sectors like usage of leaf color chart, usage of soil health card, neem-coated urea. So I would little want to emphasize on the other sectors, particularly transport, biomass burning, and the power sector. As far as biomass burning is concerned in rural areas, particularly the burning of firewood, coal, and other things for cooking purpose, we need to have arrest this burning, and we have to come out with the options like introductions of the LPG in the rural areas, so as to stop the emissions which are coming from the household burning of these particular fuels in these rural areas. One of the beautiful policy that has been recently promoted by our government as a solution is the Pradhan Mantri Ujjwala Yojana, which is launched in May 2016. And as a result of this, there is a 70 to 80% coverage in rural areas, and the local households have been provided with the LPG cylinders and the LPG gas connections, and a lot of reductions have been noticed in the NR emissions, particularly in relation to this biomass burning in the households. When we talk about the transport, we have seen that in India, majorly NOx emissions and the N2 emissions after agriculture are driven by the road transport only. So one of the very beautiful solution that I have seen recently that is promoted by government is the promotion of EV vehicles on the Indian roads, so as to phase out our diesel vehicles and the petrol vehicles as soon as possible. For that, we have a very good plan with us that is known as National Electric Mobility Mission Plan of India 2020. Again, the problem comes when we are promoting electric vehicles on the roads. We need more power, then we need to have a more burning of coal, and how to balance then for that we also need to have a equal we have to move on or switch on to the more usage of renewable energy resources as compared to the non-energy as compared to the fuel based or non-renewable energy resources. For that, India is aiming for about 500 gigawatts of installed renewable energy capacity by 2030, and out in this 500 gigawatts, approximately 100 gigawatts is only be extracted through solar energy under National Solar Mission of India 2010. In addition, I have also find that Indian government is also promoting subsidy programs so as to promote the installation of the solar panels, particularly at the individual houses, because the installation cost of solar panel is very high initially. And we have observed in the last few decades in the first phase of National Solar Mission of India was failure because of the high installation cost. For that, we have launched Pradhan Mantri Surya Ghar Muft Bijli Yojana in 2024 so as to provide the subsidies up to 40% so as to promote the individuals and promote the boost of the individuals' morals to install the solar powers on their roofs. So when I look these solutions that our government and we are already trying to have so as to fight these increasing nitrogen fluxes in our country, I myself find a biggest hope for me to going forward to see one day a very full-fledged national mission for sustainable nitrogen management in our country as a part of national government policy arena. So with this sentence, I would like to pause here. Hopefully, you all have got the substantial information through this talk. Thank you.
Thank you so much, Sangeeta. And so let's pass now directly to you, Dr. Shazla Mohammed from the Maldives National University. Tell us the situation down where you are.
Thank you, Mark, and thank you very much for this opportunity. And hello, everyone. So the Maldives National University is also a partner of the South Asian Nitrogen Hub, and I'm very happy to be here to talk about the nitrogen situation in the Maldives. So as you know, Maldives is a SID, a small island nation, and it's geographically very different. And we have a unique setup with 1,100 islands scattered across, and it stretches over the equator. So most of it is water, so 99% ocean. And due to the scarcity of space and the low fertility of the soil, there's very little agriculture happening in the Maldives. And then most of the food is imported. So the staples, rice, flour, around 90% is imported. But there are some islands like Thodu, which we had as a model island taken for the project, which grows some horticulture products like bananas, papayas. So on these islands, there is an issue of overuse of synthetic fertilizers. And because the soil is very porous, it directly seeps into the very shallow waterlands in the islands and contaminates the water. In addition, it also leaches out into the marine environment and causing a lot of damage to the coral reefs. And there have been studies which has been undertaken and there's found to establish an effect. So the other main sources of nitrogen is raw sewage, which is pumped directly into the deep sea. Although it's deep sea, it's just a few meters away from the island, and this is one of the contributions that is resulting in the high value of ammonia per capita for the Maldives because of the large volume of sewage and also possibly the food waste. And almost all inhabited islands, which is like 200 islands, there is very few islands where sewage treatment is happening before that is disposed into the sea. So it's going directly into the sea and with very few operational treatment facilities on some of the islands. And this actually affects the marine environment, the corals, the biodiversity around it. And it is also very much dependent on the currents and the way it flows. So sometimes we do get eutrophication happening around the islands. And we still have to establish if the relationship between the nitrogen and the coral and eutrophication that is happening. There's also some incidences of fish kill that were reported, and this could also possibly be due to this problem, due to nitrogen pollution. There is some strict environmental law for the resort islands, and they do have to treat the sewage before that is disposed, but this is not happening in the other local islands. So this is one intervention that we need to have to prevent the pollution from this source. And another important thing to note is the high use of fossil fuels that probably leads to the per capita high levels of N2Os and NOxes in the Maldives. So although there's some transition happening in the Maldives from fossil fuels to solar energy, but it's still very limited. So we do depend very much on fossil fuels, and our major import is actually fossil fuels, especially diesel for power, electricity. And also, in addition, our marine transport sector uses a lot of diesel as well. So these are major sources of N2O and NOxes in the Maldives. There's another source that is from open burning of the waste, but there has been some interventions here where incineration of waste has been stopped, and then the open burning has been stopped and incineration has been introduced. So which is as a result of the implementation of National Solid Waste Management Policy of the country. So these are the main sources, and we do have an issue with data availability of nitrogen sources when we're also working on the project. So there's very limited data for Maldives on this. And there has been some studies conducted under the South Asian Nitrogen Hub, but we do need to monitor the emissions for effective pollution control in the country. And that sort of sums up the major issues related to nitrogen pollution in the Maldives. Thank you.
Yeah, thank you so much, Shazla. That's really helpful. So we're going to go on to a discussion part of the webinar now. And if you're attending and you would like to ask a question, please do put a question in the Q&A box that you should find on the screen. So I encourage you to stick your questions down to our panelists. Now is the chance. And let's get the ball rolling with some questions. I'm going to come to you first, Sangeeta, about measurements. So the question is how do we quantify nitrogen flows in South Asia? And what do you actually think are the major uncertainties if you look at all those different nitrogen forms?
As far as quantification of fluxes is concerned, in my case, I have utilized the IPCC methodology where we have quantified the first fuel consumption of each individual sector. And we collected the data sets from wherever it is possible. We have collected the indigenous data sets from the individual countries. And further, we also referred to the data sets from the UN websites, from the IEA websites, and other international databases so as to fill up the gaps. Then to quantify that, we use an equation which is given by the IPCC methodology 2006 or 2008, and deploying the very updated emission factors available with us so far, that is IPCC emission factors for the NOx and N2 emissions given by the IPCC in 2008. And these so in my calculation, I basically noticed two major challenges and two major sources of uncertainties. First was the outdated emission factors. The most updated, as I said, emission factors available with us from IPCC is only for 2008. And as we have noticed in our discussion that the emissions and our sources and our scenarios of and our fluxes are continuously changes over last decades. So our purpose actually is not going to solve out by this old emission factors. We need to have a new emission factors so as to have a more valid quantification. Second was said by Shazla, lot of data gap is there in the fuel consumption, which is the main activity data sets to estimate the emissions. That data sets needs to be available in the public domain so that we can have a more reasonable and the right quantification.
Thank you. So let's
Thank you.
come over to take that same question to you, Uma, but in agricultural context. Sangeeta is talking about emissions to the atmosphere. If you look at your measurements in the field, what do you think are the most limiting factors of you getting your data sets with fresh data sets? You're muted.
Okay, thank you. Thank you for asking me the question. The main problem was actually for our crop sector. We have our own database, and for rice, especially for rice, we have our own emission factor. So we are not using the IPCC for calculating the nitrous oxide emission from rice sector, but for in case of other cases, they are using the IPCC impact factor. And the main problem was the data set. The data is mostly coming from research institute, but for other cases for road transport and other data, sometimes we use the FAO stat data. When we calculate, then we found that it is quite higher than our country emission that we are calculating. And for reporting most of the data, we have to rely for UNFCCC report and National Data Inventory report. And sometimes we get some data from the published paper. But however, the most limitation is the data are not up to date. Means
can I just push you a bit harder on this? It's the same question, but for an immediate reaction, which is you've been collecting lots of data in the South Asian Nitrogen Hub on this. You're submitting your data to UN processes. Do you see an opportunity for changing the reference numbers as a result of the data you've collected? Is there a mechanism for how you can change the UN reference numbers with your evidence?
Yeah. But I feel that most of the data we extracted from FAO stat data. So maybe if we could generate our own data set from our research or other places, then we can refer more strongly. And for impact study data, we don't have the direct data for nitrogen. What is the impact on nitrogen pollution on human health or biodiversity or water sector? Like Sangeeta can say that this river area polluted by nitrate or water, but we don't have direct actually the data. So really, in these cases, like SNNM data from Bangladesh, we did for crop sector, and the data we provided here from Bureau of Statistics and FAO stat, but mostly data, but not from our own generated data. So we always refer we always give the references of that data, that FAO stat data or UNFCCC data or some other data, but our country own data, we don't have so strong data set.
Okay, thank you.
Sector,
let's come on, because I want to come back to a point Raghuram was making. I think Sangeeta made it as well, about the importance of nitrogen oxides, particularly because it's been going up so fast. I sort of got the impression, Raghuram, when you spoke, that nitrogen oxides was really the most important one. But is that really what you're saying? Or are you saying that we need to take account of all the nitrogen impacts? Can you just guide us a bit more clearly on that?
Yes, so both from the point of view of the total emission in terms of gigagrams per year, as well as in terms of the growth rate per year. NOx is the fastest growing, a combination of nitric oxide and nitrogen dioxide. And we also know that the particulate matter pollution has been growing consistently in this part of the world. And WHO has been showing year after year the countrywide or the region-wide apportionment of number of deaths due to respiratory illnesses or those attributable specifically to PM 2.5. And some out of some 6 million deaths, 7 million deaths attributable to PM 2.5 pollution all over the world, more than 2 million of those deaths happen in South Asia alone. And out of that, and this is not very recent data, this is like some 4-year-old data, so that today's data might be even higher. And out of that, some 2 or 2.5 million deaths, some 1.7 million deaths were attributed to India alone. So these are the kind of, and these are far higher than the number of people we lost during COVID per year, averaging those 2 years of COVID pandemic. So this is exactly the situation. But some of these estimates extrapolated from data elsewhere or estimates not directly traceable to particular communities, the national governments are not ready to adopt them or act on them. But these are the figures. They are quite staggering.
That's really helpful, Raghuram. I'm going to just pick up on that one thing you said, which was, if I understood rightly, that air pollution deaths were larger than the deaths related to COVID. I think that's a very powerful statement. It would be great if we can clarify whether that is nitrogen air pollution deaths or total air pollution deaths, and maybe the time period. But I encourage you to think about that we can finesse those numbers a bit more, but it looks like that's something really worth focusing on. But I want to come to a question in the chat, which is from Dong Gil Kim. Greetings from Ethiopia. Thank you for sharing the great experiences. He's wondering if anyone has an idea about managing both nutrients such as nitrogen and recurrent drought in the region. And is there some thinking we can add as to how to address drought and nitrogen together? And I wonder if this is a question for you, Tapan.
Yeah, it's a very interesting question. Work is going on, but there is no foolproof technology for managing both drought and nitrogen. In fact, the other way, soil moisture relations towards the positive side and the nitrogen has been worked out quite a lot. And there is the suggestion of managing the water. In case of drought, it is the reverse, where the water is a rarity. There has been some studies which shows that maybe managing the nitrogen at a particular pattern can give some respite to the crop, especially during the early growth phases, which is quite susceptible to drought impact, as well as the crop at the latter stage. Probably that is little difficult to manage, but the early stages, by managing the nitrogen, we can increase the crop growth, so that making it enabled to withstand a drought to a certain extent. But till now, there is no foolproof technology for connecting nitrogen management and drought per se.
Can I just push a bit more on this issue, which is obviously drought is a limiting factor on crop growth, and that can be a situation that leads to low nitrogen use efficiency and more pollution. And I'm wondering if there are situations where there's drought that people try to compensate by putting more fertilizer on, rather than realizing that in fact you need to use less in a drought situation. Is that a risk that needs to be managed?
Maybe Raghuram would like to answer it.
Yeah, what you're saying is right, Mark. Ultimately, it's a question of how you manage drought is directly related to what kind of agriculture system you adopt. It varies with crop also. If you're cultivating cereals in a drought-prone area, then the amount of improvement you can get will be very marginal. But if you're cultivating legumes, pulses, especially, a lot of legumes have far lesser requirement of water as compared to any of the major cereals. And in fact, outside the Americas, Africa has a fairly healthy ratio of legume to cereal, that is 40:60, but it could actually improve upon it. And livestock manure is one thing that can, if the recycling can be improved both for urine and manure, that also brings moisture into the soil. It brings nutrients, and it reduces the dependence on fertilizer. Because if you can't add a lot of fertilizer, especially the mineral fertilizer or the inorganic fertilizers, when there is less water. So that will increase the losses, that will waste the money. It will not give you the results you need. But if you are bringing back manure and urine, it is a much better way of giving both water and nutrient to keep the soil moist. And and in the case of legumes, you may not even need a lot of such nutrients anyway. So that's the approach we have to take in a drought-prone area. Use crops that use less water, require less water, use more legumes, bring more integration of livestock and cropping, use better management of livestock waste into cropping, both nutrients as well as the water that comes with it, including urine.
Okay, thank you. So I want to come back to impacts just now, and we heard Raghuram emphasizing this number. More people died from air pollution than from COVID. I think this is a very powerful message. We just need to finesse those numbers on the nitrogen share, the timescales. But let's think about the ecosystem impacts. And Shaza, you're from the land of coral reefs. They're beautiful places, full of biodiversity. We hope they are. But tell us how excess nitrogen can impact coral reefs and marine ecosystems, and what you see as the particular threats in the Maldives.
Thank you, Mark. So as you know, we are very much reliant on our tourism, which is the main GDP sector for us, as well as fisheries. It's all dependent on our marine resources. So the marine resources being impacted is quite a huge issue for us. And so when we have excess nitrogen from agriculture runoff and leachate or sewage directly disposed into the sea, there's an issue with the marine fauna as well as the corals, right? And so this is thought to have significant impact on the marine ecosystems, and the excess nitrogen can lead to algal blooms and block sunlight and reduce oxygen, harming the coral health in the ecosystem. So it disturbs the whole system, and it also can contribute to coral bleaching. So there is already danger from climate change impacts due to the increase in temperature on the corals and leading to bleaching. So this could actually magnify, the pollution could actually magnify this impact. And so we had some reports about mass fish kills and eutrophications, but we still need to establish by more rigorous monitoring and gather more data.
Mm-hmm. And obviously you've got your problem with agriculture, you've got about wastewater. Just thinking about the Maldives, what do you think would make a difference to mobilize practices differently? So you mentioned that much of the sewage systems, for example, are putting raw sewage into the ocean at present. You've got problems with island water lenses. From your perspective, what might turn things around? Is it awareness, new technology? What dimension do you think is most important?
Yeah, we need to implement many strategies. One of the important things is develop a comprehensive national nitrogen management plan and identify the sources, implement regulations, and monitor emissions, as I said, for pollution control, effective pollution control. Also improve the waste treatment, as you mentioned. So we already have systems in place for the resorts. So if we can have that in for the local islands, and for Thodu, as you know, we under the project we are actually establishing a system where to monitor the impacts, right, with use this of new technology. So introducing new technology and waste management systems, because for Maldives, because of the setup and the small land area, we need sort of new technology, I guess, because otherwise we'll need more. We don't have that much space to establish the plants, the treatment plants. So I guess this would make a difference. And then implement sustainable practices for the agriculture islands. So optimize fertilizer applications, and maybe other things like crop rotation could be introduced, right? And another thing could be nature-based solutions to have buffer zones around the islands, and wetlands to naturally filter the excess pollution, nitrogen pollution that reaches the marine ecosystems. And then finally, the public awareness and stakeholder engagement education should be there.
Yeah, thank you. Thank you so much. Now we have another question in the chat there, which is about when there are new fertilizers out there, especially in India. There's nano urea, nano diammonium phosphate, it seems, and also neem coated urea we know about. But how does one take on board the evidence for new coefficients when you're making emissions inventories? And I think that comes back to also the question of, is there enough data to make new coefficients for that? I wonder, Tapan, if you want to give a brief answer, but feel free to pass it maybe to Sangeeta if you prefer.
I think nano urea, there is some there was some confusion, but now it is a little bit cleared. One thing is that nano formulation of urea applied directly on the plant at the terminal stage can reduce the third split of urea, prilled urea, which is applied to the field. For DAP, I don't want to say, but DAP is a more stable one than nano urea. Now, reducing the third dose of almost 1/3 of the applied fertilizer as prilled urea by spraying nano urea may be helpful, but we have not yet calculated the entire dynamics of how much nitrogen savings can be there. But obviously, applying directly on the crop, it makes it available to the plant and readily usable. That much I can tell, and it requires more data to find out the impact of nano urea in nitrogen management of crops.
Yeah, thank you. We do need to wrap up shortly, and I think it's worth just also remembering that in the South Asian hub we did not make experiments with nano urea, but we did with neem coated urea, and found out that the neem coated urea had several benefits, including nitrogen use efficiency increase, including reducing nitrate leaching and nitrous oxide emissions. So there are new data emerging from that. But let's begin to just wrap up, and I want some very short answers from you, because we only got 2 minutes left before we hand over to Ning to close the webinar. So you get maximum 20 seconds to give your answer. And the question is, what is the single most important thing that should be happening in your country for nitrogen management going forward? The single most important thing. So you got 10, 20 seconds for a very short answer. Let's start with you, Sangeeta.
As far as goes, I think I feel it is the introduction of EV vehicles, particularly to arrest the NOx and N2 emissions from transport sector, which is the major issue right now.
Very good. Thank you. E-vehicles. Shazla from Maldives.
Probably the National Nitrogen Management Plan, which will cover everything.
That's a very smart answer. Okay. Uma.
For me, I think we are using a lot of chemical fertilizer in crop sector. So the first thing we have to think that how we can increase the nitrogen use efficiency and in crop sector. And also we have to reduce the use of prilled urea and we have to increase the urea supergranule or other things. And one more thing I need to say that for animal sector, that one also need to be in consideration because a lot of
very good. Thank you. That was. We have to go and tap out and very quick answers.
Yeah.
Single most important thing
for South Asia. I think I will answer for South Asia. South Asia, I think the appropriate nitrogen management to reduce the excess use of nitrogen fertilizer, that is possible by several measures. And now I think the development of nitrogen use efficient varieties are coming up. I think that can be further explored.
Very good. Thank you. Raghuram.
I think restoration of legume-based cropping systems and keeping livestock and animal systems closer to the cropping systems is the best way to bring maximum improvement in nitrogen use efficiency and reduce fertilizer dependence.
Thank you. Very clear message. Tariq, you get a quick moment for 10 seconds.
I would prefer to go for national action plans. Because once you have plan, then you can go for it.
Very good. Okay, well, that's the message for everybody from South Asia. We're going to thank you so much for joining us and pass over to you, Ning, to close the session.
Okay, thank you very much, Mark. So on behalf of the Secretariat of the Global Partnership on Nutrients Management and the UNEP Nutrients team, I would like to extend our heartfelt gratitude to Professors Raghuram, Tapan, Ume, Sangeeta, and Shasla for sharing their expertise and insights on nitrogen assessment in South Asia. We also deeply grateful for Professors Mark and Tariq for your great support in making this webinar a success. A special word of thanks goes to my colleague Vanjiru, whose dedication and hard work were instrumental in organizing this event. As many of you are aware, the 7th session of the United Nations Environment Assembly will be held from the 8th to 15 December 2025 in Nairobi, Kenya. In the recently released report of the Executive Director of UNEP titled Priorities for Advancing Sustainable Solutions for a Resilient Planet, tackling nutrients pollution has been identified as one of the top 5 global priorities. Addressing this challenge requires robust science-based recommendations, such as those presented in today's discussion. Looking ahead, we are committed to fostering continued collaboration with policymakers, researchers, the private sector, NGOs, and the international organizations to confront the complex issues surrounding nutrients pollution and to advance sustainable and impactful solutions. With that, I would like to declare the webinar closed. Thank you once again for your participation and your contributions. Thank you. Bye-bye.
Thank you, everybody.
Thank you, everyone. Thank you so much.
Thank you,
For
guys.
giving me this
Thank you
beautiful
again.
opportunity. Thank you.
In the next
Bye.
webinar.